So the situation during the Age of Enlightenment, approaching the beginning of the 19th century, is as follows. Physics is the queen of the sciences, clearly with a theoretical and language basis that makes it mature. Biology has remained descriptive. Now, what is the philosophical basis for science as we approach the 19th century? Well, we began with René Descartes. We had Francis Bacon's contribution of the scientific method. And so far, everything still allows the inclusion of some of what we might call the Thomistic approach. But at the beginning of the 18th century, we have the philosopher David Hume. And David Hume's contribution to philosophy of science is the following. First of all, let me say that David Hume was an avowed atheist. And David Hume saw it as a real problematical situation if science included any acknowledgement of a creator. So David Hume suggested that science should be, first of all, empirical. That is, it should be observational and should depend on experiments for gaining its information. That is, empirical observation. Secondly, David Hume suggested that science should only deal with the material. Science should have nothing to do with what people call the spiritual realm of things. This is taking off on Descartes' dualism, that is the mind-body split, and saying, let's ignore the material that we call mind, that we call spirit, that some might call soul, and let's concentrate only on the physical, on the material world, as the proper object of science. So Hume makes that suggestion. And thirdly, Hume suggests that science should not be concerned with causes. Now, by causes, I mean this in the Aristotelian fashion. Hume decides that science should only be concerned about the form of nature and the material of nature. That is, what nature is and what it's made of, rather than who made it and what its purpose is. And I'll come back to those Aristotelian causes a bit later in our series. So with that suggestion strongly in place, the philosophy of science of the 19th century starts to approach what comes to be called logical empiricism or logical positivism, a movement that lasted into the 20th century in science and whose demise only came about with the advent of quantum physics at the beginning of this century. Now, at the beginning of the 19th century, then, science finds itself focused on the material world. Now, in order to do experiments, in order to be an empiricist the way Hume suggests, looking around you at the world, it's apparent that it's very complex, and therefore experiments are very difficult to do. So the approach of science becomes reductionist. Now, reductionist is a kind of interesting word. Reductionist means that we're going to take the world we see and break it into simpler components. There are three ways of being reductionist that we want to consider. The first way is a very practical way. In order for science and the kind of biology we're going to talk about to be practiced, it's almost by necessity that you have to break the world up into smaller components. That's called methodological reductionism. In other words, the only way I can do an experiment in the laboratory is to take a complex system and begin to focus on one of its components. The second kind of reductionism is the reductionism that says the only way I can understand this complex world, the only way I have of knowing about it, is by examining those fine components, those details of the world. In other words, I can't gain knowledge of the world considering it in all its complexity. I can only consider it reduced to smaller, more manageable subunits. And that kind of reductionism is called epistemological reductionism. Epistemological reductionism. The third kind of reductionism, I think, is the most dangerous for us as scientists. And that is the kind of reductionism that says, not only do I do my experiments by dividing the world up into smaller pieces, not only do I think that that's the only way I can gain knowledge about the world, but I actually think that the world itself is as it is because of those units. In other words, everything is composed of the smallest subunit, which let's say is at the atomic level for our purposes, and that all properties of the world we see can be explained simply by the properties of the smallest subunits. That's called ontological reductionism. So we have three kinds of reductionism at work in science. The practical kind, the kind that we follow to gain knowledge. we say, and the kind where we actually believe that the world is no more than the sum of its parts, that things around us are no more than the sum of its parts. This is the situation at the beginning of the 19th century. Now, the 19th century is a fascinating time for science. Physics has moved to the point where it has now reached the level where people believe practical things can come from it. And in fact, practical things are starting to come from physics and its investigations. Chemistry, in fact, has come along the way behind physics and has started to be able to describe the world in terms of the elements that make up the world. Biology is still descriptive as we approach the middle of the 19th century. Now, there's a very interesting time in the 19th century, the decade of the 60s, from 1859 to 1869. Is a fascinating decade for biology. Fascinating in the sense that we can look back on it historically and see certain things that happen, which today we think, wow, why didn't they know this at the time? Why didn't they see this juxtaposition? There are three events that happened during that decade of interest to us today. The first is that in November of 1859, a book is published in London by Charles Darwin. It's called On the Origin of Species.